you're ready, you can give a thumbs up. I think number 1. Yeah, all right. Okay, great. Okay, yeah. Hi everyone. I'm based in Singapore. I'm Naveen from AngelHack. So it's 11 p.m. over here. But wherever you are, good morning, good afternoon, or good evening. Welcome to our Polkadot 101 workshop, the very first workshop for this hackathon. So I'm also excited to introduce our speaker for this deep dive. We have Radhakrishna from the Web3 Foundation with us today. So Radhakrishna brings a wealth of knowledge about Polkadot and the Web3 space. So today's session is more of is more for novice level developers. So whether you're new to blockchain or just curious about Polkadot, you've come to the right place. So here's a taste of what we'll be covering today. The workshop will equip you with the fundamentals, diving into its vision, core components, how it stands out in the blockchain space. The innovative multi-chain architecture with the relay chain, parachains, and parathreads will also be explored. We also shed some light on Polkadot's security mechanisms, governance, and developer tools like Substrate and Polkadot.js API. So yeah, buckle up and get ready to unlock the full potential of Polkadot. So let's give Radhakrishna a warm welcome.
Thank you very much. Do you want me to get started? Did everybody arrive or?
Yeah, I think more are streaming in, but we have posted an announcement on Discord, so they'll come.
Okay.
All right, you can start.
Cool. Thank you very much for having me here. Very excited to introduce Polkadot to all of you. So I've made this Polkadot 101, just like a 101 course, assuming minimal understanding of how things work within the ecosystem. So I try to give you pointers in this talk, which will be helpful when you go into the other deep dives and workshops planned this week. Okay, so let's see what I have here. So just to give you the context of, why there was a need for a blockchain like Polkadot, you'll have to go back in time, not as behind to the creation of Bitcoin. That's fine. Like back in 2015, that's when blockchain started to generalize. So there was Ethereum, which was trying to be like this world computer, right? So anybody could deploy programs, which they call smart contracts, on the blockchain and then do computation on the blockchain. So this Ethereum, generation blockchains, which originated at the time, they were never, designed for communicating with each other. So that wasn't part of the actual design of the blockchain network. The earlier designs of those blockchains, they weren't like designed to scale either, so think about like how computers sort of evolved over time. The initial versions of computers are always, not that performant, right? So the performance keeps increasing as you improve on the architecture and design. So there isn't much customization available. There wasn't any concept of like on-chain governance. Yes, you could build DAOs on top of, blockchains like Ethereum with smart contracts, but to be able to govern the future of the chain itself, there was no, governance aspect added to the chains. So most of the decisions were taken outside the chain, um, by groups of developers or influencers or etc. So that makes like even upgrades difficult, because being a decentralized network, you'll have to coordinate with a lot of unknown entities out there to make an upgrade to the existing network, right? So that's where we were in 2015. um, and then the concept of Web3 started to, kick in. Like people were interested in doing more with blockchain networks, branching out from the use case of just cryptocurrencies. People were looking at like different applications that could enhance internet as such, what we have. So Gavin Wood, founder of Polkadot, and co-founder of Ethereum, has coined this term Web3, where users have the ownership of their own data, identity, and their future. So this particular aspect of internet, it can be powered using blockchain technology. So different networks have spawned after people identified the issues, that people understood that blockchains shouldn't operate in silos. They should be able to talk to each other. Blockchains should be customizable. There should be some on-chain governance. So getting all these ideas together, like multiple like blockchain networks have been created, designed, of which like Polkadot is one of them. So all of these blockchain networks are focusing on decentralization as well as interoperability. They don't want to work in silos. They want to talk to other blockchain networks out there, and somehow be part of like this Web3 ecosystem. Now let's see how Polkadot sets apart itself from other blockchain networks I've mentioned in the previous slide. So Polkadot's architecture, when it was conceived back in 2016, it was meant to address all the problems that I cited earlier on this talk, right? So there should be scalability, there should be interoperability, there should be high levels of security, and you know there should be some form of governance through which the network makes its changes, and also the upgrades that are made to the network, they should be seamless. So all of this was envisioned ground up from the design to implementation, to ensure that Web3 is accessible for millions. So when I put this statement, I'm not just saying it out, in the air. So I have actually the data and proofs that we are actually catering to like millions with the technology that we've built at Polkadot. All right, so let's step back and sort of look at Polkadot's technical design, right? So as you're in this hackathon, uh, I'm assuming like you're familiar with technical designs of blockchain networks in general. So let's look at like Polkadot's technical design without making it too simple. So Polkadot, it has what's called a relay chain, and it has blockchains that run in parallel. That's why they're called parachains. So so in this figure, like you can see this blue circle inside as like Polkadot's relay chain. So it is facilitating all these pink blocks, which are parallel blockchains that are running on top of it. So, so what's happening here is you can call Polkadot an execution sharded network, because every individual blockchain parachain that runs on Polkadot, it has its own execution engine. When I say execution engine, it's the state transition function. It's the business logic of that particular blockchain. One could be doing DeFi, one could be focusing only on identity, one could be focusing on Internet of Things, or take any use case for blockchain technology. You're able to sort of create a blockchain for that, embed the business logic in it, and run as a parachain on Polkadot, right? So that's what Polkadot achieved. Um, and it achieved like way back in 2020, along with Near protocol, which has achieved like sharding. So when people hear about the sharding, they immediately relate this to scalability, right? So the ability to run different things in parallel gives you some form of like scalability. So Polkadot achieves this through execution sharding. Yeah, so in a way you can think of Polkadot as, it's not a single chain, it's a multi-chain. There's relay chain, and then there are these parachains. Each parachain can be unique. Each parachain can have its own logic. It need not run the same functions that Polkadot runs. So hence it's a heterogeneous multi-chain protocol, right? So Polkadot overall secures all of these individual like blockchains with some form of pooled security and interoperability. So that's the beauty of becoming part of like Polkadot ecosystem. So the blockchains, when they become parachains, they can enjoy like Polkadot security. So right from block number one, they're going to be secured by Polkadot's multi-billion-dollar economic security, and they can easily communicate with all the other chains that are available on the ecosystem. So, in simple words, for those of you who are not very technical and you're listening to this talk, so Polkadot can be thought of as a set of blockchains that can talk to each other and work together securely. So, I mean, given the time of like 25 minutes for this talk, I'll try to finish what I have and then open the floor for questions. And I'm also like not monitoring the chat if you're already posting some questions there. Anyway, so Polkadot's vision, what we firmly believe is that the future of Web3, it's not based on a single blockchain. As a matter of fact, even Polkadot doesn't consider itself like a full solution. Like we always believe, you know, we always believe that there is a multitude of functionality that can be leveraged across the ecosystems to make Web3 a reality, right? So there's this one size fits all. It's not something that is real. So if you're trying to think that only one chain will be the future of like Web3, then that's not aligned with like Polkadot's vision. So we believe Web3 depends on openness and interoperability. That's why we also focus a lot on building bridges to different ecosystems in a trustless way. Okay, so to take a look at, so I mentioned these individual like blockchains, right? So these blockchains are running in parallel, um, and they're called parachains. So they can be custom built using Polkadot SDK. This is like the software development kit for building these blockchains. It comes with a lot of functionalities inbuilt. As you'll see that there are over like 50 parachains that are already live on Polkadot network, right? So we have Asset Hub, which takes care of like assets, whether fungible or non-fungible, collectives, which is sort of like a blockchain dedicated for DAOs in a way, Bridge Hub to be able to create like trustless bridges to other ecosystems. And then we have like Akala, which is a DeFi focused chain, Moonbeam, it's like Ethereum on top of like Polkadot, and so on and so forth. So just to give an example, there could be many blockchains running on top of Polkadot, each blockchain specializing in its own use case, or it could also be a generic blockchain like Ethereum. So that's the amount of flexibility you get building like a blockchain with Polkadot SDK. So as you'll be hearing about Polkadot more and more this week, so some of the terminology that you should be aware of is the relay chain. So I've mentioned it briefly earlier. So relay chain is the central chain, like the main Polkadot chain, right? So if you look at this, so Polkadot chain in this snapshot has like about 18 million blocks. You can see these parachains being like, so the parachains have like their own block number. For instance, Asset Hub has like 5 million blocks in it. Collectives has 2.6 million blocks in it, and you can see all of these are individual blockchains that are being validated by the Polkadot validators, and being their proofs are being included in the 18th million block on Polkadot. So just to give an idea, so the 18 million blocks that you see here, it's part of like Polkadot relay chain. So that's part of like the central, that circle that I'm showing in this figure. So that relay chain is sort of considered layer zero, right? So it's below the layer one functionality. So it doesn't even have smart contracts. I mean, you're able to like transfer balances on Polkadot. You are able to stake your tokens. You're able to participate in governance, etc. But there's no provision for you to deploy smart contracts on Polkadot network itself. So all of this functionality is offloaded to layer one blockchains, which are called like parachains. So they are the ones that people use to have these advanced functionalities like smart contracts, like building dexes, building identity solutions, etc. And also the relay chain, it can connect with like other ecosystems, like let's say Ethereum or like Kusama or Cosmos. All of this is possible through these bridges. So these bridges are also an abstraction of like parachains. So they're also connected to the relay chain through a slot, which is connected to parachains. Cool. So what makes Polkadot like unique and sort of like sets it apart from other chains out there? So one of the key design decisions made early on before like Polkadot even launched is, what kind of virtual machine should Polkadot use? Should it use EVM, or should it use a much more generic like virtual machine? So that's when the designers of Polkadot decided to use like WebAssembly. So WebAssembly is like this virtual machine that could like run even on browsers at near native speeds. It's very generic. It's very flexible. You're able to run a lot of like how would I put it? Yeah, so you're able to run arbitrary programs on it, right? So you and the core logic of the blockchain, it's all written in Rust programming language, and Rust is known for its like it's a low level language. It's able to give you like high control over the memory, and you need that level of efficiency for building highly performant like blockchain networks. Cool. So basically, Polkadot SDK, it comes with a lot of palettes. So these are the modules that you could drag and drop into the blockchain runtime. So these palettes can be used to sort of bring functionality to your blockchain. You don't have to write it from scratch by yourself. So let's say you want to have like a blockchain with some account balances in it, some tokens in it, and have the staking enabled right from block one. You're able to do that with Polkadot SDK. And that gives you as a developer a lot of technical freedom, right? So you're able to start with a template node. You'll see that um, you're able to create like a blockchain network right on your computer. Like you can compile the Substrate template node, run a blockchain node, see the basic functionalities like work. And then if you want to add additional features that are not available on the Polkadot SDK, you're able to build them by yourself. You can add those palettes to Substrate frame. And if you're not happy with the primitives that Substrate is actually giving, you could also modify those primitives. The Substrate core libraries, they are also up for like, you know, you're able to like edit them as well, or change them, or completely replace them with your own logic. So a few chains out there have done that. So for instance, LF0, if you're familiar with that blockchain, so they've used like Polkadot SDK to create their Substrate chain. So they basically swapped the entire consensus engine. So they're using like DAG based consensus, and they're able to achieve finality in like 1 second. So Substrate and Polkadot SDK offer that levels of customization. Okay, so if you take a look at like Polkadot's node, then it's able to communicate with other nodes through lib peer-to-peer protocol. This was developed by IPFS people. Um, so, and I've already mentioned to you the business logic of blockchain itself, the runtime. It's executed in WASM. So Rust is the programming language that can be used to create this WASM blob. And then most of the Substrate nodes, like I said, they ship with like grandpa consensus. But again, like you're free to like swap it with your own if you're running a standalone chain. And a parachain, when it's loaded as a parachain on Polkadot, it doesn't have consensus on its own. The parachain sort of offloads the consensus to Polkadot, right? So this grandpa consensus is not even needed for not even needed for the parachain network. So parachain can focus only on its business logic and offload its security and consensus to the relay chain, which is Polkadot. So one of the things that is very flexible in Polkadot is the architecture of its node. So for instance, in Cosmos, if you're trying to have some kind of validator network that is like giving security to multiple networks, that validator has to download the binaries of all those networks. It's going to be very heavy. Whereas like Polkadot nodes, they differ from that in the fact that you're able to have the node and you're able to swap the business logic, the runtime of it, like just the video game cartridges. Like for instance, if I want to load Astar, Akala, and Moonbeam and run their state transition logic, I could just download their WASM file, which is about like 1 or 2 MB, and then with that, the entire node sort of validates their blocks. So the node itself is that flexible, and this is the key for like Polkadot's shared security, right? So we are having like this architecture where there are different parachains, and the validators of Polkadot are being assigned in groups to all of these individual parachains. So what happens is, let's say uh, there is this parachain where the validators are sort of validating the transactions in that particular parachain. They download the state transition logic, the runtime of that parachain, and then they check whether the transactions are following the state transition function. And only then they sort of finalize that parachain block. And when this validator gets swapped and gets assigned to another parachain, they'll download that parachain's runtime code. So the parachain itself, it's a blockchain network. So you might ask yourself, like, yeah, hey, what kind of nodes does a parachain run? So those nodes are called as collators. So the job of the collators is to just collect the transactions that are happening on the network, um, package them into this proof of validity blocks, and then send them to Polkadot validators for validity checking. So to show you this live on the network, so let's see what's happening here. So Asset Hub has like 5 validators assigned to it, like validator group 27. As you'll see when I'm speaking, those validators will get shuffled. A new set of validators got assigned here, validator group 28. So and this shuffling goes on and on, like probably every minute. So now what happens is these validators, so they're fetching the block number 4,483,000, whatever, and validating it using the Asset Hub WASM code. And if that block complies with the code, then it is included and then backed in the relay chain. And then the parachain can be confident that all the transactions within that parachain block are sort of final, right? So if you look at it, Polkadot achieves its finality in 20 seconds. And then, so if a parachain takes like 12 seconds to create a block and sort of send it to Polkadot, so within 30 seconds, like parachain blocks are achieving their finality. Okay, so let's take a look at the time. Yeah, so I'm doing okay. So now Polkadot, not all the parachains are developed by teams and developers like you. Some of them, they're built by the Polkadot core developers. So they're part of this sort of family called as system chains. So right now there are 3 system chains on Polkadot. You'll see more and more getting added. For instance, the staking, governance, identity, these functionalities need not stay on the relay chain. They can be moved to the system chains. Along with this, you can also see that soon there'll be a core time chain that will enable like core time sales on Polkadot, and so on and so forth. So yeah. So when I mentioned that Polkadot is looking at Web3 for millions, so I'm talking about this. So you can take a look at how efficient Polkadot architecture is, which enables like almost 1,000 times cheaper than Solana and 100 times cheaper than Optimism and 10,000 times cheaper than Ethereum. So these are the fees for transferring an asset like USDC. Um, you know, from the exchanges to a particular account on like Asset Hub. Yeah, so that's the fees that it takes. It's $0.001, right? So no other network is able to match such level of low fees. And this fees is also predictable. So there is no spike in sort of the fees when, so let's say if a lot of activity happens on Ethereum, there's a lot of spike in the fees that you have to pay to make a transaction. So such level of unpredictability is absent in Polkadot. So that's what uh, the technical design of Polkadot makes it possible for developers to have like a predictable model so that they can ship products that are able to benefit from that predictability. Okay, so there's also this liveness concern about a blockchain network. So there are few blockchains that stop, or they take a while to restart, or stuff like that. So Polkadot doesn't suffer from this because it has hybrid consensus. So the way it works is the block production. It's a separate process. It's separated from block finality. So Babe is like the block production algorithm, and Grandpa is like the block finality algorithm. So they both work separately. So Babe guarantees like liveness, and then Grandpa guarantees like finality. And the beauty of Grandpa is that it can finalize like chains instead of individual blocks. So even if the finality is lagging behind um, by like 50 or 60 blocks, Grandpa is able to finalize all those blocks in a single shot. So yeah, so this is one of the innovative consensus mechanisms like Polkadot uses to guarantee liveness. So Polkadot also has an interoperability solution. So it is powered by XEM. So now XEM is like cross consensus messaging. It's like a language. It's a format. So these different parachains use XEM language to talk to each other. So day by day, the number of cross-chain transactions are seeing increase in the volume. So the other thing is, I mentioned to you, we believe in interoperability. So there's also Polkadot Bridge Hub, which was live from 2023. Recently, it came into like spotlight because we are launching um, a trustless bridge to Ethereum. Hopefully, this sort of kickstarts a lot of activity within the ecosystem by bringing the assets from Ethereum. You already saw, uh, you know, doing transactions with Polkadot on Polkadot is like very cheap. So having assets from an ecosystem like Ethereum in Polkadot and doing some form of like trading or manipulation here will be very cheaper than doing it uh, on any of the L2s on Ethereum. So the other thing is we have governance as well as treasury. Treasury has the funds for projects like yours. Like if your project is successful and is looking for like some funding, we have that available through governance and treasury as well. And the governance is also used for making changes to the network. So one of the key features of Polkadot is that it has forkless upgrades. So a typical blockchain network, forks whenever there is like an upgrade. On Polkadot, all the upgrades happen through on-chain governance. So whatever network change you're trying to make, it will be part of the block itself. Once the upgrade happens, the new block is produced with this upgraded code. So this innovative design enables like forkless upgrades. Um, and yeah, so I'll end this talk. I know I don't have much time here with the upcoming features, right? So right now, Polkadot sort of parachains take 10, 12 seconds to create like a block with the consensus optimizations called asynchronous backing. Parachains can now create like blocks every 6 seconds, and they can use a lot of execution time within those blocks as well. So this is going to improve the throughput by 8 times. So it's a significant upgrade for the Polkadot network. It's happening sometime this month or like next month. So there's also going to be, because I mentioned to you earlier, the cross-chain action within Polkadot. To ease it further, there's like an asset conversion palette added to Asset Hub. So this sort of enables fee payment, in different tokens. So you need not have even like, so parachains need not have dot tokens. They can pay the fees, the cross chain transfer fee in their own native tokens with this palette sort of live. Also, Polkadot enjoys this multi-asset treasury. So far we've seen the treasury only with dot tokens, but now natively it allows the treasury to hold assets which are like different tokens like USDC, USDT. Um, it could be Ethereum as well. So once we have the trustless bridge operating, so there's no limit to the kind of assets the treasury can acquire and hold. So one of the key use cases is I don't know if you're familiar with Polkadot Technical Fellowship. So there are about like 70 Polkadot Technical Fellows out there. Some of them also get salary from the treasury in like USDC. So it's possible through this clever architecture. Yeah, and Agile Core Time, it's actually launching on Kusama tomorrow. So you're very much in the flux of like all the improvements happening on Polkadot. So this will eliminate the parachain auction model. You should be able to deploy your parachains on demand, or like in a using a bulk core time. So all of that will be possible from tomorrow on Kusama, and once it's successful on Kusama, it will be added to Polkadot runtime as well. So stay tuned for this update. This is going to make a lot of parachain developers' life easy. Yeah, so you should be able to purchase like cores. So cores are like these slots through which parachains are connected to the relay chain. And yeah, there are numerous UIs that are available for making this an easy process. So Beefy, it's like bridge efficiency enabling finality yielder. It's like a consensus layer as well. It's going to let ecosystems like Ethereum, Solana, or Cosmos, or others trying to understand Polkadot state easier. The proofs are like very light, and this is already like live on Polkadot. And this enables like Snowbridge, which is going to launch very soon on Polkadot Asset Hub. Um, and finally, Polkadot is leaning towards abstraction and generalization of block space, right? So you see many blockchains out there as like these ghost chains, like they don't have many transactions, but they produce block like every 6 seconds or every 10 seconds or whatever. So to be able to efficiently allocate resources so that you only produce a block when you have to, or if you want to produce a lot of blocks. So let's say there's a 5 million NFT drop somewhere, and then the network should be able to handle the incoming traffic. So at that time, you should be able to create as many blocks as you want. So the network should be elastic. The network should also enable you to, if there's not much activity going on, to produce blocks only when you have to. If you want to share the block space with someone else, you should be able to. All of this is possible with all the upcoming features on Polkadot. So for every blockchain use case out there, you're seeing like projects on Polkadot utilizing this technology stack. Yeah. So we talked about, okay, so there have been millions of inscription transactions. There was no fee spike. So we already established that Polkadot works for millions, but how do we take it to billions, right? So that's where we want to sort of have these properties for this blockchain. We have it has to be unstoppable. It has to be the apps have to be upgradable. So the apps like bandwidth, it should be unlimited. And finally, can we create like feeless applications, right? So all of these properties, um, so Polkadot SDK sort of gives you the flexibility to achieve all of these. And as we are speaking, like Gavin Wood is giving a talk in Token Terminal Token 2049. It's happening in Dubai. So he's unveiling like the architecture of Jam Chain, which sort of tries to get all of these properties onto a blockchain. So so if possible, try to watch that video once it's published. And yeah, so with that, I close the session today. I'm open for questions. I'm sorry if I ran over my time, but yeah, so happy to take some questions now.
Thank you so much, Rod. I think that was a really insightful session.
I had to cram a lot of info in 25 minutes, so I tried my best.
Okay, I think we do have a question.
Okay, so there's a question on the this slide, right? Okay, so the first thing is, it has to be unstoppable. So now unstoppability, it's the ability any sort of blockchain network achieves through sufficient decentralization, right? So Polkadot already sort of has this. If you heard of like Nakamoto coefficient, you can already see that the network itself is sufficiently sort of decentralized. So we are confident that if someone deploys like their application on Polkadot network, there won't be there won't be uh, any incident where it can be stopped. So the other thing is upgradable. So I've shown to you right from the Polkadot network core state transition logic. Everything on the network is sort of customizable. It's all modularized as well as sort of upgradable. So the ability to so Polkadot calls itself a meta protocol, right? So it's able to rewrite itself. So now you're seeing like Polkadot has this staking functionality that is tied to the number of parachains on the chain. Now with core time, it doesn't make any sense because it's getting rid of the auctions models, um, and there could be like multitude of new parachains onboarding to like Polkadot. Now how does the protocol upgrade itself? So there is a way. So Polkadot has this OpenGov through which it can say, hey, I'm replacing the existing staking logic with this new logic. Everybody votes on it. If the network sort of agrees that this update should make into like the core protocol, it is done. So that's a possibility. There's also possibility for smart contracts to be upgraded, which is beyond the scope of today's talk. But anyway, so that's possible. So the other thing is unlimited. So there's nothing like unlimited. I would say unbounded, right? So let's say the use case that I talked about. So I'm doing this 5 million NFT airdrop, and I want the resources from the network. I have the money to pay for it, and I want my users to have the fine experience. Nobody should sort of experience some sort of downtime or inaccessibility to the network. Can I scale uh, with the demand that I have? And for that, Polkadot is having this elastic scaling solution. So you're able to purchase cores on Polkadot Relay Chain on demand and sort of assign these tasks like NFT airdrop. It's not dependent on other um all of the NFT airdrop claims, they're independent processes, right? So they're not dependent on one another. So that sort of enables creation of these blocks, um, and then elastically scale based on the demand that you have. So Polkadot SDK already gives you that form of customizability. And the final thing is feeless. So in Ethereum network, like everything you have to do is tied to Ether. So even if you do something on one of Ethereum's L2, ultimately that L2 chain needs to anchor that in Ethereum with ETH, right? So on Polkadot, there is a way for you to sort of like how would I put it? Circumvent that. So right now the parachains, they lock their dot, and then they get access to 2 years of security from Polkadot, right? So in those 2 years, they're not spending even a single dot to interact with the relay chain to finalize their blocks. So this gives the parachains the ability to come up with these architectures where they need not have a token at all, or they need not have like a native token, and still enable like users to submit transactions with some form of like rate limiting. So Polkadot SDK sort of gives that ability for you to create like feeless like parachains, um, with some form of like rate limiting architecture that you decide to have. It could be like some form of identity driven interaction or so on and so forth. But yeah, so it is also possible. So I hope that gave you an idea of what I meant with this ideal Web3 application properties.
I think we have another question from Peter.
Yeah, so we
Uh,
come from Ethereum space and we want to go for XCM track. What testnets should we use for building? Yes, so if you're trying to test like Ethereum, I'm sorry, XCM based interactions, right now, I mean, so there is Rococo, but I think the access to it's sort of gated. So there's Passio network, which one of the ecosystem teams sort of started. So I would let I'm dropping that in the chat. So there's actually a faucet for that as well. So and also the Web3 Foundation started like the yes. So there is certainly like a toolkit. I'll have to check with the developers and then sort of give it to you. Uh, Yep. So unfortunately, like the XCMP, the permissionless way of establishing channels between parachains, that feature is not live yet. Uh, right now, the interaction happens through the relay chain, so which requires this HRMP like activation. Um, so Thomas and Peter, I think I can talk to Levine and then sort of have this information sent to you, um, you know, through email or so. I can do that like tomorrow.
yeah, that'd be perfect. Um, I'll make sure to send it across to the participants. Yeah, so that'll be tomorrow.
Yep.
Mhm. Thank you. Looks like that's all that we have tonight. I think we can end the session if we don't have any more questions. Thank you so much for your time, Radha. It's a
Yep.
really great
Sounds good.
session. Yeah. Everything will be recorded and uploaded to our participant guide. We can always refer back to the recording. This for the rest of the participants. All right. I think we can
Yeah.
end
Just
here.
want to say hi to Mario as well. Mario from Softclaw. Nice to see you again. Yeah. Right. Thank you.
Yes. Thanks. Thanks everyone for attending. All right. Bye everyone.
Yep. Bye bye.
Mhm.